All right. Hello, Gabriel. I can hear you. How you doing?
Hi, everybody. Can you hear me okay?
I can indeed. It's all working fine. Your screen will appear in a few seconds, and I'll let you take off. But very welcome to the GDSN for the first time from D-Fend. It's a pleasure to have you, and we look forward to your presentation.
Pleasure to be here.
All right. You can go ahead and start with your talk. Thanks.
Hello, everybody. Pleasure to meet you. My name is Gabriel from D-Fend, and I'm here to talk about cyber counter-drone concepts for control and continuity in challenging environments. We at D-Fend Solutions, we provide our counter-drone solutions aimed specifically for the sensitive environments to provide complete situational awareness and control over the drone threats. A little bit about our product and about who we are and where we are dispersed around the world. We are a global company with global offices worldwide. At the moment, we're providing our solution to a wide range of various customers from various domains and various defense sectors, whether in the sector of defense, homeland security, private enterprises, and we protect large-scale events and sensitive airspaces worldwide. And this is where I want to really put an emphasis on, because you had various speakers yesterday, and you will have more speakers today talk about drone technology and where drones are going and how their technology is advancing, and the amount of different applications that drones are being used in today. So I don't need to talk too much about that, but we know that the drones are everywhere and that their technology is advancing to a degree where they could be used to pose as a risk, whether by terrorists or criminal activities. So drones used maliciously, or just drones used carelessly by careless users that can cause harm in various domains. And what I want to put an emphasis on today are the challenging environments or the sensitive environments in airspaces where if these drones pose as a risk, it is a lot more complex to counter that threat. To provide the situational awareness for the operators using counter-drone solutions. And secondly, and more importantly, how do we neutralize that risk? And not only how do we neutralize it, but how can we neutralize it while maintaining operational continuity or maintaining safety in the environment of what we wish to protect. And that leads me to the next slide, where I'm going to talk about the ideal counter-UAS solution for challenging environments, as I think it may be. And that is a full-spectrum counter-UAS solution that does everything as an end-to-end system, from detecting the rogue drone in the environment, tracking its movements, classifying its make and model, providing you with extra situational awareness as to perhaps pilot's position or takeoff location of that drone, painting a full picture for the counter-UAS system operator. And moreover, if that operator sees that drone or those drones in plural pose as a risk to the operational environment or to the environment of which we wish to protect, we have the ability to safely take control over that drone, disconnect the rogue UAS or the rogue drone from its original pilot, and move it over and land it safely at a predefined safe zone of the counter-UAS solutions or system operator's choice. And that's very important, and that's the ideal counter-UAS solution in D-Fend's mind, is in terms of cyber takeover, we're not only providing the accurate location of that drone, or if you may, look at the screen whereas we're painting a dome of protection over an environment, we see the drone's movements and we have the ability to fully take control over that drone while using cyber takeover technology. And we can do that safely. And the immediate benefits of that is that as that solution is surgical, it is non-jamming. So I'm doing that without interfering with the operational environment. I'm not using any kinetic solution, so I'm not sending anything physical out into the air, and I'm not dependent on line of sight. And that, in in my mind, is the ideal counter-UAS solution for a challenging environment, because not only can we paint a full picture and have that situational awareness provided, but we also have the ability to neutralize the threat, mitigate the risk by taking full control over the rogue drone and landing it safely, all while maintaining operational continuity by not jamming, not sending any kinetic solutions into the air, and not being dependent on line of sight. The next slide is going to go a little bit into detail about the specific capabilities or the necessary capabilities for control and safety across the rogue drone incident lifecycle. So if the previous slide was just painting that picture in a macro point of view, this slide, we're going to dive a little bit deeper into each specific part of the life cycle, or each specific aspect in terms of the capabilities that are relevant in order to provide a full counter-UAS solution. And the first thing that a counter-UAS solution working off of RF Cyber is going to need to do is to detect the risk and to provide the system operator with an alert. Now, though this is an educated audience, it's going to be pretty easy to explain how it works. Lots of times when I'm talking to different customers, we have to really go into the basics of things. But in terms of UAS operation or drone operation, there's a ground control station and there's a drone, and usually they have a unique communication line between them. RF detection and cyber technology solutions would detect that RF between the drone and the remote control, and it's going to provide the operator with an alert telling the operator, hey, there's a drone communication in your operational environment. Moreover, through that dedicated line of communication between an RC and its drone, lots of information is being sent in both ways. The ground control station is what's telling the drone to fly up, fly down, fly left, fly right, and the UAS or drone is sending lots of information back to its remote controller. RF cyber technology utilizes that line of communication and extracts crucial information from that line of communication. We focus on extracting the information, or RF cyber technology can focus on extracting the information that's relevant, such as the live GPS location of the drone. So not only are we detecting that there's drone technology in the vicinity and providing the operator with an alert, these technologies have the ability to extract the live GPS location that the drone is sending as remote control, decodes the information and displays it for the system operator on the user interface. That way, we're detecting the drone communication, providing the operator with an alert, and also receiving the live GPS location of that drone, tracking its movements live in GPS accuracy. In addition, now that we know that there's a drone out there and we know its exact live position and the distance from perhaps what we defined as the area of protection, it's important to also gain more and more information about that UAS in order to provide situational awareness as to what the system operator is dealing with. Information such as the identity of that drone. Not only are we providing, or can RF Cyber Solutions provide you with the make and model of a specific drone, say not only that it's this type of communication operating on so-and-so frequency, but we're also letting the system operator know, hey, there's a Phantom 4 Pro or a Mavic 2 Enterprise or Parrot Anafi in your environment, or a do-it-yourself drone model that's out there. RF cyber technology also has the ability to provide its own unique identification to each drone. And in that case, say you have 10 of the same drones out in your vicinity or out in your operational environment of the same make and model, RF cyber technology has the ability to provide its own unique identifier to each drone. That way, although you have, say, 10 of the same drones in your environment, you're able to distinguish between each one, which enables the RF cyber technology operator to perhaps authorize a specific drone, right? We can create a list, say, of authorized drones and unauthorized drones, although they're from or of the same make and model. This is very important for many different operational domains and security, as well as private enterprises, say an airport that has their own security drones or own drones that are used that they are using for maintenance, and the RF cyber technology operator would want to categorize or classify those drones as authorized, whereas any other drone, although they're from the same make and model, which hasn't been authorized, will be mitigated or neutralized upon entering the predefined protected area, or just manually neutralized and mitigated by the system operator. In addition to then providing the operator with detection of the rogue drone, as well as its live location, as well as the make and model, and perhaps also classify it as an authorized or unauthorized drone, RF Cyber Technology provides system operators with crucial information, such as the takeoff position of the drone, and in some cases also the RC position, the live remote control position. So say a rogue drone pilot would take off from a specific location and then make his or her way to a different environment, perhaps to hide away from the original home point. RF Cyber Technology can provide both of those locations to the counter-UAS solution operator, thus painting a full situational awareness picture for the operator of detecting the rogue drone or rogue drones, providing the operator with their live location, classifying the make and model of those drones in the environment, and providing information such as the takeoff position as well as the remote control location. And then the system operator can decide what he or she wants to do with the environment. If they see that these drones or these rogue drones pose as a risk or as a threat to the operational environment, RF Cyber Technology can then move over to the other part of the neutralization or drone mitigation. Again, all in the same end-to-end solution. One sensor provides you with that full scale or full spectrum of capabilities. We can then move over to mitigate or neutralize the risk. And as you can see on your screen, it's important to provide multiple scalable options for drone or threat mitigation. Okay, you can begin with just an option to disconnect the drone pilot. So we see that drone in the environment, we see that it poses as a risk, or we see the multiple drones in the environment, see that all of them pose as a risk. We can then proceed to mitigate. And when a system operator of RF Cyber Technology would select to neutralize a drone in the environment, the system sends a surgical command signal to a specific drone to disconnect from its original remote control. And then the scalable options of mitigation would be just to fend off the drone, just to remain in that disconnecting phase. Again, I'm reminding that it's surgical and it's non-jamming. I'm communicating specifically to the rogue drone. We can disconnect it from its pilot, and then the drone is going to conduct its fail-safe mechanisms, whether it would return home or hover and land in place. An addition option to the scalable capabilities of drone mitigation and neutralization would be to force the drone to go back to its original home point and land at home. Thus, the pilot is not going to regain control when the drone comes closer to his or her vicinity. Rather, the drone is just going to go back to its original takeoff position and land safely. Again, keeping the protected environment under control. And last but not least, the RF Cyber Technology operator can move over to fully take control over that drone. So we're not just going to disconnect it from its original pilot, and we're not going to leave it by sending it back home. Rather, the RF Cyber Technology operator can moreover reprogram that drone with new waypoints to land at a predefined safe location of his or her choosing. And that's the full capability set of RF Cyber Technology, from detecting the rogue drone, providing the live GPS location of that drone, classifying its make and model, having the ability to classify it as an authorized or unauthorized drone, being provided awareness as to where the drone came from, where its pilot is, and having the ability to safely mitigate the risk and neutralize the threat, either by sending it back to its original home location or by reprogramming it to fly waypoints to a newly safe, predefined safe landing zone of the system operator's choosing, thus providing with full operational safety in the operational environment and maintaining complete control over the drone. I'm going to move over and discuss traditional technologies and how those traditional technologies, although operated very, very well, may struggle and have shortcomings when operated in challenging or in sensitive environments. And those original technologies or traditional technologies that are used in the realm of detection are technologies such as radars, optical solutions, RF direction finders, and acoustic solutions in some cases. Now, we love those technologies. They're traditional, we're used to them, and we know that they work. However, they work well in some environments, but when talking about sensitive environments or challenging environments, whether it's dense urban environments or environments with obstructions, we know that they have their limitations. Okay, traditional technologies such as radars or acoustic solutions suffer from false positives or RF refractions in some cases, whereas it has the problem with distinguishing between the different flying objects in the vicinity. And if caused with RF reflection, the radars are going to provide the system operator with many alerts, although not all from the same and specific drone that's out there in the vicinity. Moreover, traditional detection technologies such as optical solutions would have problems working in areas which are non-line of sight, or would have problems with bad weather in specific locations. So we know that those traditional technologies, however great they may be in some environments, dealing in more challenging environments such as urban areas or dense urban environments, would have trouble detecting the rogue drone, either by false positives or just trouble handling the non-line of sight in the environment. The next category would be traditional technologies in the realm of mitigation. These traditional technologies can be technologies such as RF control jamming and RF and GPS jamming. In addition, traditional technologies would be, for mitigation, would be those of kinetic solutions. They could be net throwers, they could be drones that go and catch drones or that ram into other drones, and they can be high energy devices, laser and microwave devices that burn the drones while in midair. And again, those technologies are great and they work. However, in some environments or in sensitive environments or challenging environments, say, I don't know, if you're an airport and you want to protect your airspace, or if you're at a mega event in a stadium or a mega sporting event, using these traditional mitigation technologies could pose as a bigger risk than the drone itself that's in the vicinity. Since traditional radio control and GPS jamming are going to cause signal disruption. Now, we know that that's very effective in terms of disconnecting the drone from its pilot. Thus, the drone is going to conduct its failsafe, which also can be a risk at times. We know that in sensitive and challenging environments, we can't always conduct these jamming solutions, right? In addition, kinetic solutions would be great for catching a drone, but it has the risk of causing collateral damage. If I'm shooting down a drone, I got to make sure that that drone is going to land safely, or else it's just scary to not know what's going to happen with that drone if it falls down on a crowd of people, or if it's going to fall in an area or drop in an area where it's going to cause more damage than we aim to prevent. And that was a little bit about traditional technologies, and however great they may be, it's just to show that they have their own shortcomings when operating counter-UAS solutions in urban environments, in sensitive environments, and operationally challenging environments. That's why sensitive environments requires the next generation approach, or the RF cyber approach, in terms of drone takeover, where in the detection realm of the situation, the outcome is going to be fast and accurate detection. By utilizing the RF channel, we're going to detect that RF communication by extracting crucial information and specific information, validating that that RF signal that has been detected is that of a drone. We're creating fast and accurate detection with no false positives. In addition, by depending on the RF communication link, you're not dependent on line of sight. However helpful that the line of sight may be, it's not completely dependent as those of optical solutions where we would actually need the line of sight with the UAS. Using RF cyber technology, line of sight may help for gaining more range, but you're not dependent on that line of sight for detecting the rogue drone in your environment. And in the realm of mitigation, the RF cyber is going to keep a safe environment by safely disconnecting the specific drone from its specific remote controller pilot, and then having the ability to reprogram that drone with new waypoints to a new safe landing zone. Thus, the original drone pilot's going to be disconnected from the UAS. That UAS has been successfully reprogrammed and is safely flying a predefined safe route to a safe landing zone, thus providing sensitive airspace protection while maintaining that operational continuity. We know that in cyber takeover, while ensuring that operational continuity, we know that that's key for continuing in the realm of communications, transportation, commerce, everyday life. We need to provide that safety, that situational awareness of what's happening in our operational deployment environment, and B, providing with that safety to maintain operations while neutralizing the drone threat surgically and safely, how important that is for maintaining operations across all domains, whether it's the defense sector that need to maintain their operational continuity by maintaining their communications or not disrupting their communications. Moreover, in airport domains or critical infrastructures where, again, they cannot disrupt signal communications, GPS communications in the environment, or just commercial everyday life where neutralizing the threat in traditional manners is going to be a problem if it's not done safely and surgically while maintaining control over the threat in all steps of the process. And that's the first part of the presentation that talks about the solution of cyber RF takeover in terms of that full spectrum, end-to-end operational solution for detection, tracking, classification, providing crucial information such as takeoff position and RC location, while enabling with the same sensor and in the same solution to neutralize and mitigate the threat surgically and safely, whether for a single drone or for multiple drones in the operational deployment environment. Now, let's talk a little bit about all the different types of drones that are out there, right? And the biggest limitation that an RF cyber takeover solution is going to have is, of course, it's a library of drones. So we know that there's all different types of drones that are being flown out there, whether it's the commercial high-endurance drones, those drones that can fly long ranges, maintain great communication between the ground control station and that of the drone, high video quality, can fly long distances, and the larger of those UASs can also carry substantial payloads. There's a whole other sector of the do-it-yourself drone market of having that flight controller, pairing it with telemetry radio models, and building it on your own frame that you constructed from scratch. That's a whole other domain of UASs that are out there. In addition, they are the smaller, more consumer-based Wi-Fi drones, some of them with great extended Wi-Fi capabilities, and we're seeing more and more of those drones come out to date. And some of those smaller, I would say, low-endurance drones that are used for different cases and different measures sometimes. But all of them are out there, and all of those drones can be used to cause risk, and they could be a threat in the different operational domains and the different sectors. RF cyber technology has a limitation of library-based solutions. That's why it's crucial for vendors of such technologies to focus on which of those technologies they want to implement and how they can provide a robust library with the crucial UASs that are out there in the market. And it's important to constantly research and analyze the drone market, see what drones that are out there, which drones are used for malicious attempts, and statistically seeing which ones are out there and which ones have been used. In addition, to see which the best-selling drones are out there, or to see the different shifts and trends out in the market in order to implement and upgrade the RF cyber library with the most crucial drones that are out there. And that we know today that there's commonly supported drones that are very or relatively easy to implement into an RF cyber technologies supported drones library. But I would say customers out there need to take into consideration that if they're searching for that RF cyber technology, they have to search for an RF cyber technology that also deals with the major threats, the high endurance drones that are out there in the market, the do-it-yourself drones that are out there in the market, the ones that can fly long distances, the ones that can carry heavy payloads, and that the ones that are most likely to be used in malicious activities are the ones that, if used carelessly, would cause the most amount of damage. Because RF cyber, although perfect in many domains, if you have a drone flying out there, it could be 10 feet away from the sensor. But if it's not implemented in the drone's library, the system is going to be completely blind to the fact that there's a drone being flown out there. And that's why unique differentiators and vendors that are providing these RF cyber solutions are differentiating in their libraries as to supporting the capabilities that we mentioned before of detecting the drone, locating its exact position, classifying the drone make and model, having the ability to uniquely tag a drone as an authorized or unauthorized drone, providing information as its takeoff position or RC location, in addition to providing the ability to safely mitigate and neutralize the threat by disconnecting the pilot and reprogramming that drone to fly a safe route to a predefined safe landing zone. And it's crucial to differentiate between the different drones that are out there on the market and to select an RF cyber solution with the biggest amount of drones that are relevant for each customer out there in terms of the threat environment that they are facing. In addition, it's important to mention that with RF cyber technology, what's relevant today may change tomorrow and may not be relevant tomorrow. And that's why it's crucial to continuously provide updates and upgrades to the system with the new and emerging threats that are out there. We see that new drones are coming to the market every day, and it's crucial that those drone technologies be implemented into the supported drones library as soon as possible. And that's why it's important for Counter-UAS RF cyber technology vendor to continuously research the market, analyze the market, anticipate the new emerging threats, and proactively build the solution to meet the next generation threat or the threat that's yet to come. In addition, it's important to have the RF cyber technology enabled to integrate with external control systems. We know that the drone threat is increasing, and the regulations in the world of utilizing UAS in the environment, whether it's with line of sight or BVLOS or beyond visual line of sight, we know that UAS traffic management systems are being deployed or are being implemented to use to date. In addition, such technologies that drone pilots may be required to use, such as providing their drone with a UUID, so that these UAS traffic management systems could have a good situational awareness of the environment, it doesn't provide that full hermetic solution in terms of drones that will not be registered or listed. So it is important to have the RF cyber technology enabled to integrate with these control systems or these global control systems and international control systems in order to provide that full situational awareness of both those registered drones as well as the drones or UASs that are not registered, or what we can call them rogue drones in the environment, thus providing those UTM systems with full situational awareness of what's happening in the environment. In addition, RF cyber technology, as perfect as it may be, and why we think, or I think it's the ideal technology for challenging and sensitive environments, it's not perfect, and it needs to have the ability to be integrated and implemented into multi-layered defense technologies as well. So to have the ability to combine this RF cyber technology solution with additional technologies in order to provide that hermetic solution is crucial. That leads me to the final slide of cyber takeover core concepts to ensure operational continuity and safety in an operational deployment environment will be that of full control. The system operator would need to have the ability to provide full control over the operational deployment environment. And the best way to provide that control is to not only detect and provide situational awareness about what's happening in terms of the drones flying in the operational deployment environment, but to also have the ability to safely take control over that drone and land it. And that's why the next category would be providing that safety of a safe landing zones or multiple safe landing zones in order for us to have that control as to where the drone is going to make its way after it has been neutralized. In addition, it's crucial to focus on the drone market and to, I would say, research and analyze and implement the correct drone technologies as soon as possible and to anticipate the upcoming threats in order to implement it into the supported drone library of the RF cyber technologies and solutions. And always look to the future, see what the new developing technologies that are out there, anticipate the threat, implement the ability to counter those threats in order to continually provide that operational continuity while providing safety in all the different domains and vectors that are out there. And that's it for my presentation and my slides. I hope I didn't go over time. And I would love to hear any questions that you have about the presentation, about RF cyber technology, about operational continuity, or just anything that's on your minds for that matter.
Awesome. Thank you so much for that, Gabriel. Appreciate the presentation.
Thank you.
All right, we do have a few questions that have come in. Some of the comments are from Facebook, Twitter. We had some come in through Slack and 2 on YouTube. So we may end up having a bit of a podcast back and forth about it. So let's see how we go in terms of time. The first one says, with some countries or militaries requiring an optical identification before they can issue the order to defeat the drone, is your system modular, allowing extra assets to work alongside it?
Absolutely, and that's a great question. And that was the last slide that I was, or the one before the last slide, was actually saying how important it is to integrate or to have the ability to integrate with existing counter-UAS solutions and technologies. Those would be technologies such as radars, optical solutions, acoustic solutions, because at least I know that lots of our customers, and I'm just going to talk in a general sense of the I would say security domain. Some of the domains, as the question, they cannot conduct any active measures or neutralizing measures without having a visual of the object as well. And that's why it's very, very important to have the RF cyber technology integrated, or have the ability to be integrated to existing technologies, because RF cyber technology can provide the precise lat-long or MGRS of that UAS flying in the vicinity, thus enabling the optical solution to easily focus on the target up to its capacity and capabilities. Some optical solutions can go out to as far as 2 kilometers. I don't really know in miles. I speak in kilometers. I hope you do as well. So up to 2 kilometers in terms of detecting small UASs, such as, I would say, small DIYs, but an equivalent to Mavic Mini or the Mavic Pro or Mavic 2, which is a relatively small drone, the Parrot Anafi as well, that's out there, Skydio's drones, the Aotel Evo, up to 2 kilometers. But it's crucial to have that precise lat-long or MGRS of that UAS in order for the optical solution to focus and target that drone as soon as possible and as swiftly and quickly as possible.
Okay, brilliant. And I guess that's almost a segue to the next question, which was someone who said, thank you again for the presentation. My question for you is, this cyber approach you're using fully applicable for all sorts of UAS? For example, drones, UAV fixed wings, fully customized UAS, and I guess I'll add in there, your old RC planes and helicopters.
Absolutely. So whether it's a quadcopter, VTOL, or if it's a fixed wing solution, I mean, for that matter, if it's transmitting and we're able to detect that RF emission, we're able to extract the crucial information and decode it, the flight controller and the radio models can be deployed on a VTOL, on a fixed wing, or on a vehicle, or any type of vehicle that it may be. What the RF cyber solution is detecting, it's the RF emissions of that drone or of the RC or some type of RF emission. We're detecting that emission, we're extracting crucial information or specific data packets that are relevant, decoding that, bypassing the encryption. All right, we're not, or RF cyber technology to decrypt information live. It's quite an approach, but there's different abilities and there's different ways how to bypass encryptions in order to extract the crucial information swiftly and rapidly, display that information to the user on the user interface, thus providing that crucial situational awareness to move over to neutralize the threat. And to answer the question again, it doesn't matter as to the platform, as well as or as long as the protocol or the RF protocol and the emissions have been implemented into the RF Cyber's library.
Okay, it's funny. I think you're talking about some of the things here that we have questions right on. So I'll continue with another segue, and that is, I'm worried that these methods you're talking about make use of private backdoors or unknown exploits that you have. What's to stop a private person from using this? Actually, and just to maybe frame that, you were talking about the bypass of encryption. So, yeah, maybe you can touch on that in this question.
Right. So I think that, I mean, if I'm not mistaken, the question was also towards the RF cyber technology vendors, right? How do we stop, I would say, malicious actors for hacking into our system? So there's pretty smart people that are involved in creating and deploying these solutions. And the fact of the matter is that they know how to decrypt the systems from external malicious activities while still managing to exploit the correct information of the UASs itself. But I'm going to touch on the privacy aspect of it, and it's a big aspect that it's important to focus on and to address in terms of RF cyber technology, because privacy, it's a big subject, and it is important to avoid private, I would say, matters such as the video link, right? So perhaps you can avoid privacy by not, I would say, intercepting or detecting or decoding the video link, rather just the telemetry of the drone as to where its location is. And if it then crosses over into a restricted environment where the customer, all right, whatever the customer may be, and depending on the different vectors or deployment environments, let's say they have the authorization to neutralize the threat actively, then they can conduct that safe mitigation to take control over that drone and land it safely at a predefined safe zone. But if there's no authority to mitigate the risk or to neutralize the threat, that's why it's important to have that full situational awareness of not only where the drone is, but where the takeoff position is, so you can then send a tactical solution, or say just I would say just a patrol vehicle to tell the pilot, ma'am, sir, you cannot be flying your drone in this environment. Please stop, without causing any harm or taking anybody to justice. But you can also do that as well with kinetic solutions, depending on the vector again, and depending on the deployment environment.
Okay, and just a quick one there on what you said. Does your system include siphoning off the visual data in terms of seeing what the camera or the pilot can see? Is that part of your solution, or no?
So I would like to talk specifically about defense solutions. I'll keep it in generals. I mean, our solution specifically does not. We avoid that private information, such as the video link. I can give the customer, the drone. I'll reprogram it, land it safely, and just say, do as you please with that drone. You want to reverse engineer it. You want to take out the SSID, anything you want to do with that drone. But my system avoids that. Other RF cyber technologies out there may want to take that into consideration as to how they want to exploit the data, what data they want to exploit, and what data they want to detect and intercept as per different privacy and regulations that are out there. And it is very important to take that domain into consideration when operating in the counter drone solution arena, because it's difficult. They're out there. Drones are being used for various sorts of applications just by simple, innocent users as well as malicious actors. And the regulations and the compliance and that whole environment has to be taken into consideration. And the counter-UAS solution vendors need to keep that in mind. They need to provide a full end-to-end solution, but that can also be scalable and that can also comply with the different regulations, whether the transmission regulations or that of taking possession of somebody's property as well.
Okay, yeah, great answer, and thanks for going to depth there about the why or the why not. Another question here, if you don't mind, we're kind of just shooting these at you, but there's a few of them. So that's good. The question is, what technology is behind your RF cyber method? Isn't it the RF detection method? Does it use several methods simultaneously? And at the end it says which ones?
I'm going to avoid discussing things that may be intellectual property, but in general, to go over again, we're detecting the RF that's being transmitted by the RC or by the UAS out there in the vicinity. To detect RF is pretty simple. You need an ultra-wideband receiver that operates on all known drone frequencies. That also has to be taken into consideration by a customer. An RF cyber technology that could provide that full spectrum of all known drone frequencies, as well as also frequencies that have been shifted from the regular ISM bands to operate, roguely outside of those ISM bands as well. The next layer would be, now that I've detected that RF emission, how do I validate that emission does actually belong to a drone and not just something of the likelihood of a drone, in order to avoid those falses and to detect a true drone that's in the vicinity. That's the next level. And the other level beyond that would be to extract crucial data, such as the GPS packet, enabled to extract that information, to decode it, in order to provide that precise lat long, or MGRS, of the drone itself, or the precise GPS location of the drone. Other information such as unique identifiers and how an RF cyber vendor would utilize those unique identifiers are extremely intellectual property, in addition to, of course, the whole mitigation aspect as to how does one reprogram a drone. It's all done via RF signals and commands, but the methods behind it, of course, is intellectual property.
Yeah, the secret sauce that allows the competition to happen. So
Yeah,
no problem there.
You gotta make money. You gotta make money in the business.
That's right. So look, we probably have just time for maybe 2 more questions. So this next one said, actually, this one was a quick one. It said, what did the second last slide mean by open architecture?
Open architecture, basically it means that you can provide an API to external sources, where you can just, you can share your solution with already existing customers out there, because many of the customers have their traditional technologies and they're already using their security measures. I don't know many customers that are going to say, oh my God, you guys are awesome. I'm throwing everything that I've been spending millions of dollars on for the past X amount of years. I'm going to throw it into the trash and just use you guys. So you want to have the ability to integrate your solution into their already existing technologies that they're using, while providing your API so they can extract the information from your system. And then if they have their own UIs or their own management systems, they can just receive the information that the RF cyber technology is providing and display it in any way that's easiest. Although the RF cyber technology vendors, or defense solutions for that matter, to try to provide a very easy, user-friendly interface to swiftly and rapidly detect, locate, track, classify, and mitigate the drone threat. There are existing technologies that are out there that are very set in their ways, and they want to use their already existing solutions. You have to provide an open API. In addition, you also want to have the ability to provide the correct information and scalable information to the UAS traffic management, UTM systems, that are rapidly growing and being more and more implemented, or that are implementing themselves or implemented today, so that vice versa, you can feed off of each other, and to provide that full situational awareness in the domain of registered UAS as well as rogue UASs, to maintain safety and operational continuity in different environments.
Yeah, brilliant. And look, there's a few more comments that kind of came in via YouTube itself, and I'll maybe let you answer them in the comments, because we've only got time for one more. But it was quite an interesting one. It said, you talked about applying a unique identifier per drone as good or bad drones. How long is this remembered for in the history, and are there ways this could potentially be spoofed?
There are ways around it. It's very difficult, but the system, or our system from that matter, since I'm not just generally speaking anymore, but I'll talk about our solution since the questions are specifically for the solution, they have the ability to classify a drone as authorized or unauthorized, because our solution receives unique identifiers for each drone. Once I classify a drone as an authorized drone, it's going to continually be classified as authorized until selected otherwise by the system operator. There are ways around that, since we're receiving unique identifiers in specific ways, because each drone in RC has a specific link. If a drone would select a different RC, depending on the type and model, perhaps it's going to receive a new unique identifier, and then it's going to have to be re-authorized. But once a drone has been authorized and it stays the same, it's going to continually be authorized until the system operator selects otherwise.
Awesome. Well, Gabriel, thank you so much for coming to the GDSN, giving a talk and answering the influx of questions. So appreciate your time, and hopefully we'll see you another time on GDSN.
Yeah, it was a pleasure.